Okay, we're going to start walking through page 5 of Unit 4. In class, we talked about the coefficient that's next to the x, and we understood that it's going to have an effect on the curve where it's either going to make it accordion out or accordion in. Okay, so let's just go ahead and let's fill out on page 5 now, A on the top. So you're given the curve y equals cosine of 2x. Yesterday we understood what this did. We will look at this coefficient and then we will say, okay, what's our period? Okay, now that is our coefficient that we're referring to as b. Okay, so that's b. So our period is going to be 360 degrees divided by b, in this case, which is 2. So that means our period is a 180 degrees for this curve. Okay, so that's how we fill out the period, 180 degrees. And we notice that a 180 degree period would put two waves where the normal cosine curve, just cosine x, did 1. So we're going to go ahead and say that it's a compressed wave. Okay, we're going to circle compressed because that's what the 2 does. Anytime this number is, the absolute value of this number is greater than 1, it's going to compress our curve. And then our critical points now would be, the way I do this is I start out and I write my period. So here's 0 and here's 180. Okay, now remember we're going to have 5 critical points that I want you to identify. So the easiest way to do this is find the middle one. Take 180 divided by 2, and here's 90. Then I take 90 divided by 2. Here's 45. Then to find this one, I add 45 and 90. So that's going to be 135. I know these numbers are easy now because those are part of your unit circles numbers, but if we use that methodology, we will find our critical points quite easily when we go through that procedure. Remember, we write the beginning and the end, and then divide by 2 to get the middle number, divide by 2 again, and then we add the first two numbers here in order, not to 0, but 45 and 90, you get 135. Okay, so those are your critical points. Okay, let's move down now to example 3. Okay, now it's saying let's put amplitude and period together for each of the curves below. Find all the pertinent information. So let's go ahead and do A. So A gives you the curve y is equal to 2 sine x. Now we know that since there is the b coefficient is 1, our period would just be 360 degrees, or 360 divided by 1. Okay, so that would be there. Our amplitude is the absolute value of the coefficient on the outside of the trigonometric expression. So therefore our amplitude is 2, and our critical points would be then as follows. Just follow the procedure. 0, 360, take half, 180, take half, 90, add 90 and 180, you get your 270. Okay, and so you've remembered those from before. Okay, let's drop down and do E. We're going to do the next example, E, and you should be able to do the rest, and then you're going to check down the road your work on with your table partners as well as the web when you see the solutions. Okay, first of all, let's identify the amplitude. For E, we're dealing with the equation y is equal to negative 3 cosine of 6x. Okay, so our procedures would be as follow. For the amplitude, take the absolute value of 3. Okay, so our amplitude is going to be 3. Now, to find the period, go ahead and just take 360 divided by 6, and then that's going to be 60 degrees is our amplitude. Okay, so I'm going to go clean up degree marks here. Okay, so what does that mean? To put together our critical values, we just put 0, 60. Remember, you're going to put these internal 3 numbers, so spread your numbers out, plan ahead, do the middle. Okay, divide by 2 is 30, divide by 2 is 15, add 15 and 30, 45. Okay, so those are your 5 critical numbers then for E. Okay, now we're going to talk about the bottom of page 5, which starts out the discussion of translation of sinusoids. Now I want to go ahead and just review for a second. When we did all our curves, I introduced to you the concept of all our shifts and translations will utilize the parameters. I call those parameters things that affect the shape of our curve, A, B, C, and D. Let's review real quick. When we did the curve, y is equal to A, e to the b times the quantity x minus c plus d, when we did exponents, what did we know? We said A will stretch our curve in the y up and down. B will stretch or compress the curve in the x. The C is the shift to the right or to the left, depending upon whether C is positive or negative. And then D could be positive or negative, and it could affect the up and down translation. Now, B could be negative and A could be negative, and remember, those were reflections about their, what I call, axis that we would move to find their new position of the key points, etc., that I've taught you. Now, we're going to apply the exact same methodology to sinusoids. Now, the first thing we do is the author, Mr. Schwartz, starts out with saying we could write a sinusoid as d is equal, y is equal to, say, plus or minus a b sine, let's do the sine bx. Okay, now that's fine, but where's c at? Well, really, when we realize it, we're going to add c in here. We're going to do that. Now, the first examples don't deal with a shift to the right or shift to the left. And when you really think about it, do we really need the plus or minus? Because a could be a positive number or a could be a negative number. So when we look at the case where when a is positive, we're not going to get a reflection. We're going to get what we call the normal curve. And then we're going to get the reverse curve when a is negative. So let's go ahead now and look at your graph, and you're going to see the difference of when you graph the curve. In your example, y is equal to 2 plus sine x. All we're doing is shifting the curve up 2. Okay, so when we started out with our normal curve, we had what we called our neutral axis, or our midline. The midline was y is equal to 0. Now, with this curve, we're going to change. We're no longer going to have our midline, y equals 0. It's going to be y is equal to 2. Now, let's ask ourselves, is there any really difference in graphing this? No. I could still graph a sine curve, and I know it's going to go up, and I know it's going to go back to the midline, and then it's going to come up. And you say, okay, well, what is this point, this point, this point? Well, all we did was we shifted up 2, so this is still going to be 0 degrees, this will still be 180 degrees, and this will still be 360 degrees. Now, the only difference is, what is this point? Well, this point is now the point 0, 2, because we've shifted it up 2. And this is 0, 2, and then this is 0, 2. Now let's think of what we had before. We had an amplitude of 1. So if this is y is equal to 2, and we go up 1, we should then see that this is the point 90 degrees, and then if we up 1 from 2, this is the point 90 degrees 3. And what happens when we went down 1? Well, we're subtracting 1 from the 2, so we take our amplitude and subtract it from our midline. So this would be the point 270 degrees, and it would be then, let's see, 2 minus 1 is 1. Okay, so that idea is pretty simple. Now, if d is a negative number, all that means is our midline is going to be a negative y. That's all, and so that's pretty simple. Okay, so let's go ahead and... for some reason, this recording is showing 32 minutes. I'm 9 minutes into 32. Okay, either way, let's stop for a second. I want to scroll down. Okay, now we look at incorporating the horizontal shift. Now, on page, I believe it's 5, Mr. Schwartz will talk about the fact that, it's on page 6. He will talk about a horizontal translation in the middle, or a phase shift. We commonly call that a phase shift. Now, in different fields of that use trig, we show phase shifts sometimes differently. But in our class right now, we are going to use now the form. Okay, let's go ahead and make sure we understand how I'm going to do it. I am pretty consistent with either writing it two ways in class. Either D plus A sine B times the quantity X minus C. Remember, this is what I call the argument of the sine curve. Everything here in these brackets is the argument of the sine curve, of the sine function, of the sine. So then we stretch it and then we shift it. Okay, so we understand how those things work. So what did we learn before? When C was positive, we shifted to the right. When C was negative, we'll shift it to the left. Now what we're going to be expected to do is to write every one of our sinusoids has both a sine wave and a cosine wave. Okay? Now we'll understand how the shifts go into place as we do some examples. The other thing we want to identify is the difference between what are called critical points of the wave and then what we call true critical points. We'll see how they fit together with an example. Okay, so let's go ahead, shift down to do an example. You could look at what's on the notes, but I'm going to go ahead and work through an example that's going to be on the top of page 7. So we're now working with example 4. Okay, we're going to do, we're not going to do A first because it's pretty straightforward. Let's go ahead and drop down to B. Okay, so we're going to use the equation y is equal to cosine of x minus 60 degrees. Okay, so let's identify that one. Not too bad. The only thing we're dealing with, okay, the midline. Okay, so the midline, which is the D, midline, okay, which is your D value, and that's 0, so our midline is the equation y equals 0. Okay, the next thing is we identify, is there any stretch in the y or x? And the answer is no. You notice that your coefficient in front of the cosine is 1, and you don't have any b here that's here other than 1. So we're not dealing with any vertical, we're not dealing with any vertical translation in this one because d is 0. We don't have any phase shift. I'm sorry, we do have a phase shift. We'll talk about the phase shift is to the right 60 degrees. Okay, so we're 60 degrees to the right. Why? Because we notice our C now is a positive value. Remember, we have to incorporate this negative, and if C is positive, we shift to the right. Okay, so let's go ahead and graph this really quick and see what we do. Wait, what's our regular critical points for a cosine? Wasn't it 0, 360, because the period is 360, then 180, 90, and then 270. So all we're going to do now to find the true critical points is we're going to say, wait a second, we've shifted this 0 to the right, so we just add 60 degrees to it. So here we have 60 degrees. We add 60 to 90, and that's going to be 150 degrees. We add 60 to everything else, so this is going to be 240 degrees, this would be 330 degrees, and this would be 420 degrees. Okay, so now watch how I'm going to graph this. You're going to see, wait a second, this doesn't look much different than what he's done. Okay, so I'm going to grab my straight edge, and I'm going to put my representative midline in. I'm now going to pick a scale. And an easy scale would be 4 centimeters. Okay, watch what I'm going to do. I'm going to put a critical point here, at 1, at 2, at 3, at 4, and then here's my last one. Okay, so now I'm going to draw the cosine curve. That's all I'm going to do is draw the cosine curve. Well, how do I draw the cosine curve? Wait a second, our cosine curve is going to start at 60 degrees, but let's not worry about that. Where does the cosine curve start out? Well, it starts out at 1. So there's its 1. There we have a 1. And then where does it go next? It goes to 0. And then what does it do next? It goes, I'm using my scale, it goes to -1. Then it comes back to 0. Let's see, we got 1, 2, first one, 1, 2, 3, 4, 5. Ooh, I graphed one too many points. And that's okay, because now where are we going to end up? We're going to end up at 1. Okay, so there's my cosine curve. Remember, what do cosine curves we always graph? We graph the frowns and smiles. Almost flat. Then we do that first. Remember I taught you that? And then sweep it down, come there, and then maybe turn the paper sideways if you want to. Okay, so there we have it. And there we have a cosine curve. Okay, There's a cosine curve. Now, we know that this curve goes on, so let's put an arrow. Excuse me. Let's put an arrow here. Okay, now, this is real simple. We're going to wrap it up now. This is now what? 60 degrees. And this is 150, right? 150 degrees. This is now then going to be 240 degrees. This is going to be 330 degrees. And this last one will be 420 degrees. How do we check that? Okay, what are we expecting when we put 60 into our equation? We expect an output of 1. So I would want you to now label your amplitude somewhere. Okay, I'm going to put my amplitude here for this curve is 1. Okay, or I could put a point here, which I love to see too. 60 degrees 1. Plug 60 back into your equation. 60 minus 60 is 0. Cosine of 0 is 1. Boom, presto. Okay, so we'll pick up another video down the road. So you should be able to graph some of these now. Okay, I'm going to post this, and then you could watch it. Okay, bye-bye.